All right, here we go. So today we're talking polynomials. Again, pretty vocabulary heavy. The whole lesson is for me to try to explain that vocabulary to you. So if at first glance you're like, what is he talking about? I'll make it clear. Okay, so the first thing we've got is a polynomial. A polynomial is an algebraic expression containing variables with positive integer exponents. Positive integer exponents, that's what we're looking for. Okay, so our exponents can be 1, 2, 3, 4, could also be 0. Okay, so we could also call that natural numbers. We said positive integers because you understand what that means. Okay, so that's a key. The degree of a polynomial, a phrase you're going to hear on every single problem. The degree of a polynomial is the largest exponent in the polynomial when it's been multiplied together. That's key. It's the largest exponent. But if it's in factored form, you got to think, all right, what would it be if I multiplied this all out? That's important. Zeros, you're going to hear me say this every time. If I ask for a 0, I'm going to say it in all 4 different ways. Okay, so we could say a 0. What's another way of saying 0? X-intercept, same thing. Okay, a 0 means an X-intercept. Great. What else could I say? A root. X-intercept, root, zeros, and one more. Solution. Good job. I will say it all 4 ways. So you need to know all 4 of them. They all mean the same thing. It is not the same thing as a factor. Okay, a factor is written before you set it equal to 0, but it's going to get you close to the right answer. Multiplicity seems a little weird here, but multiplicity means how many times does the root occur? And we'll explain that here in a second. But how many times does the root occur? That is the multiplicity. All right, let's go. So you can see some different degrees of polynomials and see what's going on there. Let's go to this part. Polynomials. These 3 are polynomials because your exponents are positive integer exponents. The exponent is 2. The exponent is 1. The exponent is 0. If it's just a constant, we're good. 3 and 0. 4, 3, and 2. We're all good. Those are positive integer exponents. Okay? This guy right here is not a polynomial because I've got a -1. That is not positive, so it is not a polynomial. This one right here, I've got the square root of x. That is not a polynomial because square root of x is the same thing as x to what power? That is to the 1/2 power, not a polynomial. Okay, that is not an integer. 3 over x, that thing right there, not a polynomial because 3 to the x is the same thing as 3 times x to what power? Negative first power because a -1 would make the reciprocal. 3 over x. Not a polynomial because it's not a positive integer exponent. When we talk about what is the degree, okay, the easy one, if it's all multiplied out, if it just looks in nice standard form, you're looking for the biggest exponent. In this case right here, you've got an x to the 4th, so the degree is 4. That's easy. But what if we see parentheses? It's been factored, okay? If it's been factored, you got to think, if I were to multiply this whole thing out, what would the biggest exponent be? Okay, so you got to think, I got an x here, 2x, and I'm going to multiply x minus 6 times x minus 6 times x minus 6, and then x plus 2 times x plus 2. If you were to multiply that all out, the biggest thing you would have is an x to the 6th power. So the degree would be 6. So you just got to pay attention. Is it factored, or has it been factored already, or not? Is it in standard form? Everybody good with those concepts? Let's do it. Try A, B, C, and D. Try them all with your neighbor. You're stating the degree. Okay, it's either yes or no first, and if it's yes, find the degree. Okay, if it's no, you better have a reason for no. We're doing it well. On the first row, letter A, thumbs up, thumbs down. Polynomial, yes or no? Yeah, that one's a yes. Show me the fingers. What's the degree? It's 4. So this one's a yes. Degree is 4. We're looking for the biggest exponent. Letter B, thumbs up, thumbs down. We're good. It is a polynomial. Show me the fingers. What's your degree on that guy? The degree on that one should be 3 because it's in factored form. Okay, you got to count them up here. I've got 2 right there. I've got another one right there. So if I were to multiply them all together, my degree would be 3. Letter C, thumbs up, thumbs down. Max, why no? That x right there would be a -1 exponent. That makes this thing not a polynomial. So it doesn't fit what we want. Letter D, thumbs up, thumbs down. Letter D is a no. Megan, why is it a no? Yeah, sorry. Yeah, pi is not an integer. We got 3.14. We can't have fractional exponents. We can't have anything else. That's a no. Everybody good with the first four? Let's just keep rolling to save time here. Letter E, what do you think? Thumbs up, thumbs down. Oh no, there's a 2/3 in front. That's not an integer. Doesn't matter. It's not an exponent. Okay, if that 2/3 is not an exponent. Doesn't matter. We got to do degree here. Kara, what do you think on degree here? Degree is 6. Good. She's counting them up. There's 1 there. There's 3 more there, and there's 2 there. It's in factored form, so she had to count all her x's into terms of that. Letter F, thumbs up, thumbs down. But there's a 3/4 at the end. Not an exponent, doesn't matter. It's x to 0. Degree there. Jack, what do you think degree is going to be? Degree is 8. It's been FOILed all the way out, so all we're doing is looking for biggest exponent. Letter G, thumbs up, thumbs down. That's a no. Herman, why no? Yep, no negative exponents. We don't allow that here. Letter H, it's yes. Careful here. Show me with your fingers, what do you think the degree is going to be? Good. The degree on this one is 3. Okay, the degree is 3. Why? What do you think? Yeah, this is in the middle ground. It's not in standard form, but it's not really in factored form either. It's a little bit of a combination of both. Okay, if I were to multiply this x in, I would end up with an x cubed right there, and then it would be in standard form. This has been factored. That hasn't. That x squared plus x minus 20. You could factor that thing into x plus 5 and x minus 4. Then you could count and say, oh, yeah, there's 3. But because it was like in that in-between ground, you had to do a little bit of work there. Questions? Super. Let's do some more vocabulary. Every polynomial is a smooth and continuous line. Okay? Being smooth, it's exactly what you think. Not sharp corners. What is a function that you know that has a sharp corner that is not smooth? Absolute value. Okay? An absolute value is not a polynomial. Okay? It's got a sharp corner right there. Okay? So polynomials do not have sharp corners. So no sharp corners. Continuous means you don't pick up pencil. What is an example of a function that's not continuous? The reciprocal function 1 over x. We know it's not a polynomial. It's got x to the -1 power. That's what 1 over x is. And for that one, you have to pick up your pencil to graph it. That's why we know it's not a polynomial. Okay, so every graph that we have is going to be smooth and continuous. So think about what that means. Nice long lines that make smooth, continuous turns. Okay, those are what polynomials are going to look like. I hope we make one just like that. That's super cool. All right, this next question. Don't let this be hard. Find a polynomial of degree 3 whose zeros are -3, 2, and 5. We did this in Bellwork. A polynomial of degree 3 whose zeros are -3, 2, and 5. In Bellwork, I made you find a quadratic. Here, I'm making you find a polynomial. Who cares? If I want to have these specific zeros, write them as factors. So it's x, x, x. If I want there to be a 0 at -3, what am I going to write in the factor? X plus 3. If it says 2, it's x minus 2. Instead of 5, I'm going to go minus 5. Cool. There's my polynomial. If I wanted it to be in standard form, I could multiply that out. Okay, you would FOIL. You pick 2 of them, you FOIL them together, and then you FOIL in the third. We'll do that later, but for right now, I trust your abilities in FOILing. Questions there? Super. Go to the backside. The phrase you probably haven't heard in math class before is multiplicity. Okay, Multiplicity means how many times does each root occur. So if a 0 has an even multiplicity, we are going to touch the x-axis. If a 0 has an odd multiplicity, we are going to cross the x-axis. Turning points. Okay? Your turning points is going to be 1 less than your degree. Let me show you what both of those things mean at the same time. So I'm just going to make a Desmos graph. Let's get creative. All right, so 0.2, I just throw a 0.2 in the front just to make it so you can see it. So x, tell me a root, some number between negative 10 and 10. 2 was what I heard, so minus or plus? Plus 2, wonderful choice. Okay, what do you want the multiplicity to be? What degree? 4. If we make it a 4, if I put it to the 4th power, that means that answer is happening 4 times. Is 4 even or odd? Even. Okay, so if I zoom in here, you can see that I am touching the x-axis. I went down to negative 2, I touched it and went back in the same direction. Okay, if it were just to the 1st power, oh, I'm crossing the x-axis because it's odd. If I go to the 2nd power, I'm touching it. Okay, that means that answer is happening 2 times because that right there is exactly the same thing as saying me saying 0.2 x plus 2 times x plus 2. The answer is happening twice. That's what multiplicity means. How many times does that answer happen? Okay, let's pick another one. So let's do like x plus or minus 1. What do you want the power to be? 3. Great. It's 3. So we touched at 2 because it was squared. Okay, we crossed at 1 because it was odd. It was 3. Notice what happens when the exponent was 3, when the multiplicity was 3. What happened here on the graph? What kind of shape is it doing there? Like a cubic shape, right? You can see how it goes up and kind of bends and goes back. What would the degree of this polynomial be that I made right here? 5, because 2 and 3 is going to get me 5. How many turning points should I have then? 4. So let's count. It's got 1, 2. Right here is a turning point because it's starting to bend. That's 3. Right there is a turning point. That's 4. Okay, so 1 less than what we had. When you get crazy on this exponent and you start making it like a 6, you're not going to be able to see the turning points. There should be 5. You're not seeing everything you want to see there. But for the most part, the turning point rule is correct. You're never going to have more than that amount of turning points. And 95% of the time, you're going to be able to see all of them. Sometimes you won't. Questions there? All right, last thing we've got is end behavior. Okay, and this one always trips students up, but it's something that you already know so well, that's why it probably trips you up. An odd degree. So what's a function we know that has an odd degree? A cubic function, x cubed. Show me with your arms, what does x cubed look like? This right here. It's going to start down and go up. It has an odd degree. The end starts down and goes up. Technically, we should say this. We should say, as x approaches negative infinity, y approaches negative infinity. And as x approaches positive infinity, y approaches positive infinity. I don't got time for that. Okay, that takes a long time. That means as you go to the left, you go down. As you go to the right, you go up. That's what that means in fancy words. So instead, I'm going to do this. Draw an arrow going down and then an arrow going up. That's what our end behavior looks like. You're going to start down and end up when you finish the graph. If you have an odd degree and it's negative, so think of like a negative x cubed graph. Show me with your arms. What does negative x cubed look like? You just flip it. Okay? You're doing this shape. Oh my gosh. A better shape than that. Maybe that. Okay? So in that case, you start up and you end down. I don't care if it's cubed or to the 5th power or to the 7th power. If you are odd and you have a negative leading coefficient, then it's going to open down like that. Even degree. What's a polynomial you know with an even degree? X squared. If it's a positive x squared, it's this. It's an upward facing parabola. So you start up and you end up. Anytime your degree is even and it's a positive leading coefficient. If it's negative, okay, then you're going to have a downward facing parabola. You're going to start down, you're going to end down. Those are the rules that we know. Okay, let me just pull up whatever graph I had right here. Let's pull up the one we were just working on. That one right there. So what's the degree of that polynomial? 3. It's positive, so it started down, it ended up. It started down over here, and as I went that way, it went up. So if I made it a negative in front, now it's going to start up and end down. If I made the degree even, now they're going to end in the same direction. If it's negative, they're both going down. If it's positive, they're both going up. Those are the rules of the road. Ready? We're going to put all that stuff together. Okay, tomorrow we're going to practice similar stuff, so it shouldn't be too much for you tomorrow, but we're going to make sure we can do this now. So given this polynomial on the back, we are doing 5 things. We are finding real zeros. We're finding the multiplicity, meaning does it touch or does it cross? We're figuring out what is the degree, how many turning points, and what's the end behavior. Okay, so all those different things. So let's start off by finding the zeros. To find the zeros, we want it to be in factored form, and we're going to take each factor and set it equal to 0. We're taking each factor and setting it equal to 0. And I do this first one on purpose, even though kids get weirded out by it. When is -3 going to equal 0? Never. It doesn't have an x in it. It's not going to equal 0. That's garbage. Okay? Don't let that throw you off. That does not affect our zeros. And then the other ones we just solve. X equals 4, x equals -4, x equals 1. You don't have to write it all out like that. You could just tell me the answers. I know you're very smart. Okay? You don't have to do all that stuff in between. But those are my zeros. Those are the 3 places my graph's going to cross. Part B says the multiplicity of each. Does it touch or does it cross? X minus 4 to determine multiplicity. Remember, we're thinking, how many times does that answer happen? How many times does x equals 4 happen on this graph? Just once. It's just to the first power right there. Okay? If it wrote x minus 4 2 times or it was squared, then it would happen more than once. Here it just happened once. And so is it going to touch or cross? Cross. It is an odd multiplicity, and so we are going to cross. Same thing on the next two. X plus 4, it happened one time. X minus 1, that happened one time. So both of them are going to be cross. Letter C said, what is the degree of the overall function? Show me with your fingers. What is the degree of this function? It's in factored form. We're counting them. The degree is 3. So, Abby, how many turning points are we going to have? 2. And that's at most 2. But 98% of the time, 95% of the time, you're going to be able to see those 2 turning points. So 2 points there. Last thing is end behavior. So my degree is 3. So are my hands going to go in the same way or opposite ways if it's 3? Opposite. Odd is opposite. You're going to go opposite directions. Is it a positive leading coefficient or negative? Negative. So think like negative slope. Okay, negative slope is going to start up and end down. That is my graph right there. Okay, if you have your cell phone, you can do the QR code right there. I'll pull it up on the front screen. But if I were to click on this, it's going to take me to Desmos, maybe. There it is, somewhere down here. There we go. But it's going to do everything we just said it was going to do. Okay, we're going to have zeros at -4, 1, and 4. We've got a degree of 3, so there's 2 turning points. I crossed, and I started up and I ended down. Everything I wanted's in that graph. Okay, we're going to sketch these tomorrow. Notice what the y values are. We get really big. Like this y value goes up to 44, and this y value down here goes to 108. We're not worried about that right now. They're going to get pretty big in between. Okay, what we care about is what's happening around the x-axis and the general sketch of the shape. Questions on A? Try letter B. See what you can do on B. Go. I know you're not perfectly done yet. We're finding zeros. Matthew, what did you say on zeros here?
I said 0 and 3.
0 for this guy and 3 for that guy. Take each thing, set it equal to 0, and solve. Then we're doing touch or cross. Aaron H., what do you think on 0, touch or cross there? That thing is going to cross, okay, because it's x to the first power. What about on the x equals 3? Touch. It has a multiplicity of 2. 2 is touch. Okay, don't forget that. 2 is touch. End behavior. I'm sorry, we skipped one. Degree. And we're doing degree here. Sam, what do you think the degree is going to be? Degree is 3. He's counting them up. There's 1 there and there's 2 there because it happened twice, so that's 3. So my turning points, how many is the most amount of turning points I could have? 2. 1 less than that. Then we're doing end behavior. Okay, it's odd. Hands same way or opposite? Opposite because it's odd. Opposite's odd. Which way am I going to start, down or up? Down because it's positive. I'm thinking like it has positive slope. I start down and go up as we go. Again, I just like you to see the picture. We went through at 0. We went up. We came back to 3 and we touched it. We went down the line, boop, and then went back in the same direction I came. I started down. I ended up. I had 2 turning points just like I said I was going to. Questions there? Try the next 2 with your neighbor. Go. Maybe some of the other ones we've done. -2, x squared plus 8 and x minus 1. Anyone confident in where they think the real zeros are going to happen? What do you think, Sophia? X equals 1. Good. So when we set this thing up, we're taking each factor and setting it equal to 0. Okay? So we take each factor. My pen just died on me. Of course it did. It hates me. There it goes. Take each one, set it equal to 0. Does -2 equal 0? Garbage. What happened in the second one, Sophia?
So you subtract.
Mm-hmm.
And you're supposed to square root them, but since you can't square a negative and have it be real, so it'd be just like not a real root.
Yeah, it'd be not a real root. We could solve that thing. In this case, it was asking for real roots, so I don't really need to solve it. I'm just going to say it's imaginary, and we'll be perfectly good with that one. But yes, that is an imaginary root. My last one is x is equal to 1, so we're good there. Okay, so then we're doing touch or cross. At this imaginary answer, am I going to touch or cross? It's a trick question. Neither. It's imaginary. You're not touching or crossing the x-axis. Okay? You don't have either. You're not touching or crossing because it doesn't do it. It's imaginary. Okay? At x equals 1, touch or cross? Cross because it's to the first power. My degree is going to be 3. Turning points 2. End behavior. Am I starting up or down? Starting up because it's negative. And it is odd. So we're going to go start up, go down, just like an odd cubic function.
So what's the degree of the whole function?
The degree of the whole function is 3 because it's x squared plus 8. There's 2 x's in that thing. And then x minus 1, there's a third there.
Okay.
Does that make sense? We could look at that picture real quick just so you see it. So we are only touching right there. Boom. It's really ugly. Not a whole lot of anything going on, but we started up and went down. The degree being 3 is going to throw us off there. Only 2 turning points is the most we could have. It really only looks like 1 because of the degree. Yes, ma'am.
On the test, would you want us to solve for the imaginary root, like include it?
It just depends on what it's asking for. If I'm asking for real roots like I am here, no. I don't want that included. Okay. Letter D. We're going to do it quickly because we're running out of time. So set that equal to 0. Set that equal to 0. At 0, touch or cross? Cross. At 2, touch or cross? Cross. The degree is going to be 4. Yeah, geez. Okay, 4. I wanted to not write that, but that was the correct answer. Turning point. My turning points are 3 is the most I could have. And then we're doing ending behavior. My degree is 4, so my hand's going to go same way or opposite way. Same. Is it positive or negative? Positive. So like a positive parabola, I'm both going up. Okay, both up. Let's look at it real quick. Boom, right there at 0. And at 2, I crossed at 0. At 2, I crossed as well. Notice that it's kind of a cubic function. I started up, ended up. There's 3 turning points. Okay, try the last 2. All right, let's finish this thing up. We're going through the different problems just like we did before. I'm going to go quickly. X is equal to -1, X is equal to 3, and X is equal to -5. Touch or cross at -1? Cross at 3. Touch at -5. Cross because it's odd, even, odd. Then we're doing degree. Degree is 6. Turning point is 5. End behavior. The degree is 6, so we're going the same. It's positive. It is up, up. Last one. Careful here. X squared plus 4. I'm setting that thing equal to 0. Where are my real roots going to be? Nowhere. Because if I were to solve this, I would get x is equal to plus or minus 2i. Okay, I would want to see that it's imaginary. I want to see at least that you're taking the square root of a negative. But once, okay, this is imaginary. This one, x squared minus 4, set it equal to 0. X squared is equal to 4. So where are my roots? Plus or minus 2. Real or sorry, we're good there. At plus or minus 2i, touch or cross? No. At plus or minus 2, touch or cross. And why is it cross? Because there's 2. Because think about what this means. X squared minus 4, they just didn't factor it into x plus 2x minus 2. That squared doesn't mean that the answer is happening twice. That square means there are 2 answers. They haven't factored it yet. Okay? If you factored it and got x plus 2 and x plus 2, then the multiplicity is 2. But here, it's just describing 2 different answers. That's why it's cross. My degree would be 4, my turning points would be 3, and my ending behavior would be up, up. We will do the same thing tomorrow. So if you felt like, I was just okay, tomorrow we're going to do the same thing, but